Hello everyone, in this video lecture I will be briefing upon petrol knocking, anti-knocking agents, cetane number, octane number, power alcohol and biodiesel. Gasoline knocking or petrol knocking and its mechanism. Knocking, it is a term related to internal combustion engine working on petrol. In an internal combustion engine or IC engine, a mixture of petrol and air vapor is used as a fuel and ignited by spark plug, and chemically oxidation of the hydrocarbons takes place. An important method to obtain more power from the petrol is to increase the compression ratio of the engine. Whenever we purchase a car, we always prefer for more mileage. The mileage always depends upon the compression ratio. Higher the compression ratio, higher is the efficiency. Compression ratio is the ratio of initial volume of the petrol-air mixture which is sucked into the cylinder to the final volume after compression. Generally, the compression ratio is fixed between 10:1 for an internal combustion engine. Let me discuss the whole process in detail by looking at the above diagram. Initially, in an internal combustion engine, fuel and air mixture is sucked into the internal combustion engine by downward movement of the piston. This is nothing but the suction stroke. Next, the piston moves upwards and compresses the petrol-air mixture. This is known as the compression stroke. This ratio of volume of petrol-air mixture at the end of suction stroke to the volume of petrol-air mixture to the end of compression stroke is nothing but the compression ratio. In the third step, the spark plug will ignite the compressed petrol-air mixture by releasing energy. This energy pushes the piston back and again it sucks further the petrol-air mixture into the cylinder. Thus, the continuous movement of the engine leads to running of the engine and the vehicle. Let me discuss two working conditions for internal combustion engine. One is the ideal condition, other is a knocking condition. First, I will be discussing about under ideal condition. Under ideal or normal condition, if the petrol is of good quality and it's able to withstand the pressure generated inside the engine, the combustion reaction is initiated by the spark in the cylinder, and under normal condition, the pressure inside the cylinder rises and slowly oxidation of the fuel takes place, which combines with the oxygen and few hydrocarbon molecules will activate them. The rate of flame propagation is around 20 to 25 meters per second and the chain reaction proceeds in a smooth way. We can take an example for a ethane as a hydrocarbon which undergoes combustion to produce carbon dioxide and energy. Thus the power output is maximum in ideal or normal condition. Under knocking or premature condition, if the quality of petrol is bad or it cannot withstand high pressure at the end of compression stroke, the petrol-air mixture suddenly bursts into flame and the flame propagation rises to 2500 meters per second, leading to explosive combustion. This is due to the increase in compression ratio beyond a certain value, which produces a shock wave in the internal combustion engine which hits the walls of the cylinder and piston, producing a rattling sound which is known as knocking. So knocking is nothing but a shock wave which is generated inside the internal combustion engine because of incomplete combustion of petrol and air mixture. Because of that, it produces a shock wave and which hits the walls of the cylinder, producing a rattling sound. The chain reaction proceeds at a very fast rate. The hydrocarbons combine with the oxygen to form the peroxide. In the below diagram, the two working conditions of the internal combustion engine is given. In the normal condition, petrol air mixture is compressed and the spark plug will ignite the compressed air mixture by releasing the energy. In the second condition, that is the premature condition or premature combustion, some of the petrol air anti-knocking agents. These are the reagents added in small quantity to internal combustion engine to minimize knocking and to increase octane rating of the petrol. There are two types of anti-knocking agents. One is leaded petrol, other is unleaded petrol. Leaded petrol contains TEL and TML. So let me discuss first with the leaded petrol. So TEL is also known as tetraethyl lead. TML is known as tetramethyl lead. Earlier, tetramethyl lead or tetraethyl lead was used as an anti-knocking agent since it was cheaper and effective in increasing the quality of petrol. During combustion of petrol, TEL gets converted into lead and lead oxide. These species will prevent the formation of peroxides, thus preventing knocking. But since lead and lead oxide are less volatile in nature, they get deposited in engine parts and may cause damage to vehicles. Therefore, tetraethyl lead was used along with ethylene dibromide or ethylene dichloride. Here, the role of ethylene dibromide is to convert lead into volatile lead bromide. Since lead bromide comes out of the exhaust of the vehicle along with other gases into the atmosphere, thus releasing lead into the atmosphere. But this lead is toxic to both environment and living beings as it causes health hazard. Another important problem with the leaded petrol is it cannot be used for the vehicles connected with catalytic converter. Generally, the catalytic converter is fitted to the exhaust of the vehicle. The role of catalytic converter is to convert polluting gases into less polluting gases. This leaded petrol poisons the catalyst used in catalytic converter, thus making catalytic converter inactive. So this is regarding the leaded petrol. Unleaded petrol. To overcome the problems of leaded petrol, unleaded petrol is used in the current scenario. Since leaded petrol is banned in the international market. So what is this leaded petrol? Petrol free from lead is known as unleaded petrol. Common examples are MTB, ETB and ethanol. So MTB is known as methyl tertiary butyl ether. ETB is also known as ethyl tertiary butyl ether. So these are the additives which are added to the petrol chain to minimize knocking and to increase the octane rating of the petrol. So these ETB and MTB have free ether linkage which assists the fuel in combustion and lowers the formation of peroxides and minimizes knocking. So this is regarding the unleaded petrol. Octane number. We know that petrol consists of various types of hydrocarbons. The quality of petrol is expressed in octane number. Octane number is the measure of ability of the fuel to resist knocking. So, higher the octane number, few are the chances of knocking, that is, fuel can withstand high compression without getting self-ignited. Octane refer to the hydrocarbon which has 8 carbon atom in it. It was found that fuels containing isooctane produce minimum knocking and octane number is considered or fixed as 100, whereas fuels made up of pure N-heptane compound make high knocking and anti-knocking value is fixed as 100. Hence, a mixture of isooctane and N-heptane are taken as reference elements for the measure of octane number of petrol.
So what is the definition of octane number? It is defined as follows. It is the percentage of isooctane in a mixture of isooctane and N-heptane that has same knocking characteristics of the fuel under test. Example, a fuel with octane number 17 will give same knocking as a mixture by volume of 70% isooctane and 30% N-heptane. Higher the octane number, better the anti-knocking property, good is the fuel quality. Therefore, straight chain compounds such as N-heptane knocks very badly. On the other hand, isooctane burns smoothly without any knock. Straight chain compounds therefore have high knocking, whereas branch chain compounds, aromatic compounds produce less knocking. To enhance the octane number of petrol, several anti-knocking agents are being added, such as MTB and ETB. Cetane number. It is the measurement of quality or performance of diesel fuel. The main difference between cetane and octane rating is that octane rating represents how well a fuel can resist pre-ignition due to compression, ensuring that the fuel ignites only from a spark from spark plug. However, in cetane number, it measures the delay in ignition time of the fuel. The shorter the delay leads to the complete fuel combustion. Cetane number represents the quality of diesel or the knocking characteristics of the diesel fuel. It is defined as percentage of cetane in a mixture of cetane, that is N-hexadecane and 2-methyl-naphthalene, that will have same ignition characteristics as the diesel fuel under examination. For N-hexadecane, the cetane number is fixed as 100, whereas for alpha-methyl-naphthalene or 2-methyl-naphthalene, the cetane number is fixed as 0. So higher the branch chain compounds or higher the aromatic compounds in the diesel fuel, cetane number decreases, whereas straight chain compounds are having high cetane number. Cetane number of the diesel fuel can be enhanced by adding some reagents such as ethyl nitrate or isoamyl nitrate, which will improve the quality of diesel fuel. Power alcohol. It is also known as gasol. It is the combination of gasoline and ethanol combined together to known as gasol. A mixture of ethyl alcohol and gasoline blend which can be used as a fuel in internal combustion engine is known as power alcohol or gasol. Blends containing 25% alcohol with 75% petrol can be used. Industrial alcohol containing 95% alcohol and 5% water can be mixed with petrol, but by using some blending reagents such as benzene and ether. Next, let us see how to prepare this ethyl alcohol or ethanol. Ethyl alcohol is obtained from molasses which contains sucrose. So what is this molasses? Generally, molasses is a dark brown liquid waste left after refining of sugar from sugarcane industry, which is nothing but uncrystallizable sugar. So this molasses, which contains sucrose, is converted into glucose and fructose by means of enzyme invertase from the yeast at 30 degrees Celsius. Next, the enzyme zymase converts glucose and fructose into ethanol and carbon dioxide to give the required ethyl alcohol. So in this slide, I will be discussing about advantages of power alcohol and disadvantages of power alcohol. Starting first with the disadvantages of power alcohol. Alcohol lowers the calorific value of the petrol. Next, alcohol is easily oxidized to acids, hence alcohol may cause corrosion in the petrol cylinder. Next, Alcohol absorbs moisture and as a result separation of alcohol and petrol layers takes place, especially at low temperature. To avoid this, some blending reagents such as benzene or toluene can be used. So these are some of the important disadvantages of alcohol blended petrol. Next we will be discussing about advantages of alcohol blended petrol. Alcohol blended petrol possesses better anti-knocking properties. There is no starting problem with alcohol blended petrol. Air required for complete combustion is less. Next, reduces the emission of carbon monoxide and volatile organic compounds. So these are some of the important advantages of alcohol blended petrol. Biodiesel. Biodiesel is a form of diesel fuel derived from plant or animal origin containing long chain fatty acid ester. It is manufactured domestically from vegetable oil and animal fats. It is obtained from vegetable oil such as soya bean, linseed, cottonseed, mustard seed and jatropha. Biodiesel is considered to be an alternate non-toxic and biodegradable fuel. Generally in India, biodiesel is prepared from jatropha plant, which is grown in semi-arid or arid regions. In Kolar, you might have heard this kind of jatropha plant is been cultivated in vast numbers. So the seed which is used is nothing but the jatropha seed, where this oil is being extracted, and the process of converting this kind of oils into biodiesel is known as trans-esterification. Preparation of biodiesel by trans-esterification. Before knowing what is trans-esterification, we should know what is esterification. Esterification, I think you might have heard in 10+2 level. It's a reaction between carboxylic acid and alcohol to form ester. But in trans-esterification, alcohol is made to react with ester. In this process, alkoxy group of the ester is exchanged with alkoxy group of the alcohol to form the trans-esterification product. So what is this biodiesel? So biodiesel is a mixture of methyl or ethyl ester of fatty acid obtained by trans-esterification of triglyceride oil with methanol using sodium hydroxide as a catalyst. So here in the below diagram we can see how the trans-esterification reaction follows. So the triglyceride oil is made to react with the methanol with sodium hydroxide as a base or a catalyst at 60 degrees Celsius. So the reaction mixture is refluxed for several hours. The products are mixture of fatty esters. So these are nothing but the methyl esters of fatty esters plus glycerol is obtained. The mixture is allowed to settle and the bottom glycerin layer is drawn off. The upper layer of methyl ester is washed and purified further to remove the excess methanol. The mixture of methyl ester is called as biodiesel and has the desired characteristics of the diesel fuel. So in this we are getting the side product glycerol, which is one of the important reagent in most of the food industry. So this is the preparation of biodiesel by trans-esterification process. So next is the advantages of biodiesel. There are many number of advantages of biodiesel. It is renewable and eco-friendly. It is less polluting with low sulfur content. Next, it is non-toxic and does not have unpleasant smell as normal diesel fuel. Next, it is having high lubricity which reduces engine wear and tear and prolongs engine life. It has high cetane number compared to normal diesel fuel. It is safer when compared to normal diesel fuel. Next, it reduces dependence on fossil fuels. The last thing is nothing but it is better fuel economy when compared to normal diesel fuel. So these are some of the important advantages of biodiesel. In the next slide, we will be discussing about some of the important disadvantages of biodiesel. Disadvantages of biodiesel. It increases the emission of NOx content, that is oxides of nitrogen, into the atmosphere, which leads to the formation of photochemical smog. It forms a gel-like structure at low temperature. Next, it damages the rubber hoses in some of the diesel engine. It cleans dirt from the engine, and the dirt may get collected at the fuel filter, and it may lead to the engine clogging. The last important disadvantage is nothing but it is quite expensive when compared to normal diesel. So here in the below chart we can see the biodiesel cycle, how to manufacture biodiesel. Generally it is extracted from the seeds. So the sunflower is one important plant origin crop. So from the sunflower we can remove the seed. From the seed we can go for extraction to get the required vegetable oil, which undergoes refining to form the refined vegetable oil. Next, it is made to react with alcohol to form the trans-esterification product. Along with the biodiesel, what we are getting is glycerol, which is used in food industry and cosmetic industry. So this biodiesel can be used in the vehicles, and the vehicles emit carbon dioxide, which is taken by the plants. So this is one kind of cycle what we can say how to manufacture the biodiesel. This is one and only biodiesel outlet which is present in Dakshin Kannada. In fact, the third biodiesel outlet in whole entire Karnataka. So we should be feeling proud that our district is having such outlet. So this biodiesel outlet is situated near Alake Majal, near Vitla of Bantwal Taluk. So here the biodiesel was prepared using soybean, johar and jatropha oil. So around 2000 liters per day the biodiesel is being sold in this outlet. I have been to this outlet and I have collected the information from the nearby customers that after using this kind of biodiesel from this kind of outlet, an additional mileage of 2 to 4 km was seen in their vehicles. So I recommend you people to have a look to this kind of biodiesel outlet.